Question 18, a tricky question combining several elements. Show that 6 tan 60 minus 4 cos 30 can be written in the form of root k, where k is an integer. So the first thing is this is a non-calculator paper, and they love giving trigonometry-based questions in non-calculator papers. And in this case, you've got to know what tan 60 is, and you've got to know what cos 30 is. Now, I can never remember what those values are, so I have to deduce them every time I do them. And this is how you deduce them. If I'm dealing with 60 and 30, I want to construct for myself, or draw for myself, a little sketch of an equilateral triangle. And this equilateral triangle I'm going to split. And my equilateral triangle is going to have side length 2, which means that that one there is 2. And because this is split in half, this one here is 1. Now there's a right angle triangle formed. And I can work out what this side length here is, what this height is, through Pythagoras. So that is this 2 squared, this is my hypotenuse, so 2 squared, which is 4. Take away 1 squared, which is 1, that's 3, and then I need to square root it. So that is the square root of 3. There. And then from this, I can then deduce these different things. Tan 60 and cos 30 can both be deduced from this. How? Well, that there is 60 degrees, because it's an equilateral triangle. And this here is 30 degrees, because it's half of that, 60 degrees there. And I can use this then to deduce the key things I need to know. Tan 60. So tan of 60, okay, so it's opposite of the 60 degree angle, which is that one, over adjacent. So I'm just going to rewrite this SOHCAHTOA, right, so we can remember, we all remember that. SOHCAHTOA. So tan is opposite over adjacent, so it's root 3 over 1. Right, root 3 divided by 1. Anything divided by 1 is just itself, so that is root 3. Okay, and I'm going to use this later, but this needs to be established first. Cos 30 equals, okay, so the cos of 30 is, well, what is cos? It's adjacent over hypotenuse. Here's my adjacent, here's my hypotenuse. Adjacent to the 30, right, because we're talking about the 30. So root 3 over 2. And that's what cos 30 is. I can't simplify that. That's what it is, root 3 over 2. So now I can rewrite this stuff, but with these values that I've just deduced. If you remember them, brilliant, good for you. But you can always deduce them in this way. So 6, now tan 60. So 6 root 3, because that's what tan 60 is. 6 root 3. Okay, take away 4 lots of root 3 over 2. Okay, and this is what we're talking about here. So 4 lots of root 3 over 2, isn't that just 2 lots of root 3? So that is equal to, if I do have 4 lots of root 3 and I divide it by root 2, or 4 lots of root 3 over 2, it's the same thing. It gives me 2 lots of root 3. So I've got 6 lots of root 3, take away 2 lots of root 3, which equals 4 lots of root 3. And with that, I have got myself definitely 2 marks, which I've worked very hard for. But I still haven't got it in this form. To get it into this form, I need to kind of reverse the simplifying process that we've used with surds. And I need to think, well, 4 root 3 is the same as, well, what's 4 the same as? Reversing the process. It's the same as the square root of 16 times by the square root of 3. So using my surds laws. If you're not sure on your surds laws, Hegarty Maths surds. Work on them. Okay. this I'm reversing the simplifying process. So therefore it's equal to, using my surge laws, if these are two surges, I can multiply these, and that gives me the square root of 48, 16 times by 3. And that's it. I've shown that this can be expressed as the square root of k. In this case, k is 48.